Hi all, welcome to RRO. I am Aishwarya. Today I am going to dealing about the second chapter of chemistry, 10th class. The chapter name is gas laws and mole concept. Okay, in this chapter we are going to learn the three laws. First one is Boyles Law, second one is Charles Law, and the third one is Avogadros Law. Then GAM, gram atomic mass, then GMM, gram molecular mass, and finally molar volume. So, we want to learn the three laws. For that, we need a thorough knowledge in the characteristic features of gases. You have already learned about something about the gaseous state, but we are going to little more deep. So, I am going to draw a diagram here. In this, which one represents the gaseous state? Yes, the third one, right. The third one represents the gaseous state, and other two, first one is solid state and the second one is liquid state. Okay, solid state, liquid state, and this one is gaseous state. Okay, we are going to study detail about this gaseous state now. Okay, which gases you are familiar with? Yes, oxygen, then nitrogen, hydrogen. Okay, these are in elemental state, and some are other CO2, carbon dioxide, then NH3, ammonia, then methane gas, CH4. These are in compound state. Okay, these are in element state and these are in compound state. Okay. So, now we are going to discuss the main characteristic features of gases. Each gas contains numerous minute molecules. Then, when compared to the volume of the gas, the real volume of the molecule is very less. When compared to the volume of gas, the real volume of the molecule is very less. The molecule of a gas are in a state of rapid random motion in all directions. That is, these molecules can move in all directions and it is a rapid random motion. Okay, as a result of this random motion, the gas molecules, they collide with each other and also collide with the walls of the container. This collision with the walls of the container account for the pressure of a gas. As the collision of a molecules are perfectly elastic in nature, there is no loss of energy. There is no attraction between the molecules and there is no attraction between the walls of the container. So, from the above characteristics, we can say the energy of gas molecules. Energy of the gas molecules are high. Energy of the gas molecules are very high. Then next point is distance between the gas molecules. You can see here clearly the distance between the gas molecules is also very high. Freedom of movement of atoms. The freedom of movement of atoms or molecules are also very high. So, you can write it as points. First one is the energy of the gas molecules is very high. The distance between the gas molecules is also very high. The freedom of movement is also very high. So, the attractive force between the molecules is very low. There is less attraction between the molecules and also with the container. So, we can say the attractive force between the molecule is very low. Next, we are discussing volume of a gas. Before that, what do you mean by volume? Volume is a space occupied by a substance is its volume. The space occupied by the substance is its volume. So, here I am taking one pen, and what is its volume? The space occupied by this pen is its volume. I am taking one glass of water here and a non-volume of water, and I am just transferring this water to this cup. Is there any change in the volume of this water when I transfer from this to this? No, there is no change in the volume of this liquid or this water. But in the case of gas, can we say like that? Can we say like that? I have taken 1 liter jar. Inside that gas is there, and I am transferring this gas to a next one having 5 liter capacity. 5 liter jar. Then what's the volume of this gas now? Yes, 5 liter. The volume of the gas have changed. Okay. Then now the volume of the gas is 5 liter. And again I am transferring this to a 3 liter jar. 3 liter jar. Then what's the volume now? Yes, it's become 3 liter. That is, the volume of gas is its container's volume itself. Okay, the volume of gas is its container's volume. Then next one is pressure. Here there is lot of gas molecules here. Okay, then we have said that the molecules will collide each other and also collide with the walls of container. While collide with the walls of container, these molecules exert a force on these walls. Okay. Then in a unit surface area, the force exerted by the molecules is the pressure of the gas. We know that these molecules collide with each other and also collide with the walls of the container. While colliding with the walls of the container, these molecules exert a force on these walls. So, in a unit area, the force exerting in a unit area is called pressure. So, if we know the force exerted on the surface, force exerted on the surface and surface area, total surface area, we can calculate the force exerted on a unit surface or unit area. That is what we call pressure. So, next one is temperature. We know that molecules, gas molecules moves very fastly, isn't it? Which energy is gained by the gas molecules when it moves? Potential energy or kinetic energy? Kinetic energy. When a gas is heated, we know that temperature will get rising. What happens to movement of these gas molecules? The movement also become very high. We know that when it is heated, what happens to its energy? Energy also become high. So, from these we can say that kinetic energy, the average kinetic energy of a molecule is the temperature. The average kinetic energy of a molecule, of a substance, is the temperature. We studied what is volume of a gas, pressure of a gas, and finally temperature. Then we are going to discuss the Boyles Law. In Boyles Law, we discuss the relation between volume and pressure. At that time, we keep the temperature constant. While discussing Boyles Law, we state the relation between volume and pressure and keeping the temperature constant. Here, keeping temperature constant, I have taken a definite mass of gas here in this jar, and without change in temperature, I am just transferring this gas to this jar. So, there is no change in the mass of the gas. Here, in which figure the pressure is high? That is, we know that pressure is the force exerted in a unit area. In which one pressure is high? Yes, in second one, right, second one. So, you can see in where the volume is high, here, right. Here the volume is high, but the pressure is low and volume is high. Here pressure is high and volume is less, right. This relationship between pressure and volume can be stated by Boyles Law. So, when the pressure is less, the volume is very high, and the pressure is high, the volume will be low. So, this relationship is known as Boyles Law, and it is stated by a British physicist, and he was also a chemist. His name was Robert Boyle. Robert Boyle. And this is known as Boyles Law. We can state Boyles Law. At a constant temperature, the volume of a definite mass of the substance is inversely proportional to its pressure. So, we can write V for volume and P for pressure. So, volume is inversely proportional to pressure. So, we can write V into P is a constant. There is a question in your textbook, page number 36. The air bubbles rising from the bottom side of an aquarium increases. Why? The answer we can explain with the help of Boyles Law. So, in the bottom side of an aquarium, the pressure is very high. The bottom side of an aquarium, the pressure is very high. So, the volume will be low. So, the volume will be low due to the high pressure. Towards going upper side, what happens? The size of the bubbles become very large. That is, the pressure is getting decreased when we go high. The pressure is getting decreased when we go high. So, the volume will be increased. That is the reason. That is, we can explain with the help of Boyles Law. When an inflated balloon is immersed in water, when the balloon is reached in the bottom side of the water, what happens to the balloon? Can you guess? Can you explain with the help of Boyles Law? So, when the balloon reaches the bottom side, at the bottom side we know that pressure is very high. So, the balloon gets shrinked, and at the upper side what happens to the balloon? The pressure is very low, so the balloon will be inflated. Let us discuss one problem. There is gas in this jar at 1 atm pressure, 1 atm pressure, and the container capacity is 2 liter. 2 liter. Container capacity is 2 liter and the pressure inside the jar is 1 atm. So, can you find out P into V? It's very easy, right? 1 into 2. 2 itself. At constant pressure, we have taken one dry bottle, an injection bottle, and have a rubber stopper, and here inserted a refiller, and inside the refiller we can see some ink, some amount of ink. Then this bottle is just transferred to this beaker which contains lukewarm water. Okay. lukewarm water. Can you notice the difference in the ink level? The ink level in this lukewarm water get increased or get risen. Why? What's happening there? Is there any change in the volume of gas? Yes, there is a change in the volume of gas. When the temperature is raised, the volume of gas is also become increased. So, the ink level become raised. Okay, that relation is said by Charles' law. Okay, then we can represent V for volume and T for temperature. These are directly proportional. When temperature rises, the volume of the gas also rises. If we taken out this bottle to outside, the temperature outside become decreased. So, the volume of the air also or the gas also decreases. That is, volume is directly proportional to temperature. In your textbook, you can see in page 36 a table there. We can discuss that table here. Volume can be written by the letter V and temperature by T. That is, volume is directly proportional to temperature. We can say V by T is a constant. To prove this, we can discuss one problem. It is in page number 36 in your textbook. Let's discuss. That is volume. It's a table. Volume 546 milli and temperature 273 Kelvin. So, we can find out V by T here, 546 by 273, that is 2. And the second one, 600 ml and 300 Kelvin, 600 ml gas and 300 Kelvin. Then we can find out V by T, 600 divided by 300, that is also 2 constant. Then next one, 640 ml and 320 Kelvin, 640 ml volume gas and 320 Kelvin. Okay, then 640 by 320, how much? 2 itself. Then you can find out next one easily. The question is 660 ml and 330 Kelvin, 660 ml and 330 Kelvin. So, 660 by 330, that is also 2. That is, V by T is a constant. It's clear that V by T is a constant. Okay. Then we can state Charles' law. At a constant pressure, the volume of a definite mass of gas is directly proportional to temperature. At constant pressure, the volume of a definite mass of gas is directly proportional to temperature. Okay, then V by T is a constant. So, can you explain with Charles' law? Why a inflated balloon kept in sunlight get burst? Why a inflated balloon get burst in sunlight? It is clear that sunlight, heat or temperature. When temperature rises, the volume inside the balloon will increases. So, the balloon get burst. That we can explain with the help of Charles' law. So, the third one is Avogadros Law. It states the relationship between volume and number of molecules. Number of molecules. In your textbook, page number 37, You can see a statement and some questions there. A cylinder fitted with a frictionless piston is filled with a gas at 1 atm pressure and 300 Kelvin temperature. What happens to the volume of the gas when its pressure is decreased? Pressure 1 atm. What happens to the gas when pressure decreased? We have learned that the pressure is inversely proportional to the volume. Pressure is inversely proportional to the volume. Which law is that? Boyles law. Okay. So, pressure is decreased. What happens to the volume? Volume will get increased. Volume will get increased. And temperature 300 Kelvin. It is increased. In the said that the temperature is increased. What happens to the volume? We also in Charles' law we discussed that temperature and volume is directly proportional. So, temperature is increasing, so the volume is also increasing. So, how can we increase the volume of the gas by keeping pressure and temperature constant? How can we increase the volume of the gas by keeping the pressure and temperature constant? We can add some more molecules to that. That's only the way to increase the volume by keeping the pressure and temperature. That is, we have said we can add some more molecules. That is, number of molecules is increasing. So, by keeping pressure and temperature constant, we can increase the volume by increase in the number of molecules. Okay, that is V is directly proportional to number of molecules. That is Avogadros law. So, we can state Avogadros law. At constant temperature and pressure, the volume of the gas is directly proportional to the number of molecules. The volume of the gas is directly proportional to the number of molecules at constant pressure and temperature. Okay, that is Avogadros law. So, I have a balloon in my hand. It's in room temperature and a normal pressure. So, I need to increase the volume inside the balloon. The temperature and pressure is constant. How can I increase the volume? I can just pump air to this balloon or blow air to this balloon. That is, the number of molecules is increasing and hence the volume is also increased. That is an application of Avogadros law. Is it clear? In this session, we learned about the characteristic features of gases, then mainly three laws. Boyles law, at constant temperature, pressure is inversely proportional to the volume. Then Charles law, at constant pressure, volume is directly proportional to temperature. And finally, Avogadros law, at constant temperature and pressure, volume is directly proportional to number of molecules. Okay, if there is any doubt, you may come in comment box. Do watch, like, subscribe our channel. Thank you.